This case study explores the application of stable nitrogen isotopes to reconstruct the breastfeeding and weaning practices of an ancient hunter-gatherer population from a region in Siberia. This is research I conducted with Canadian and Russian colleagues. The sites are located in the western Lake Baikal region of southern Siberia. As you can see, the southern end of the lake is not far from Mongolia, and while the winters are definitely very cold, the summers are quite pleasant. The prehistoric hunter-gatherers who lived in this part of the world from around 9,000 to 3,000 years ago have been the focus of a lot of research since the 1990s by the Baikal Archaeology Project, an international multidisciplinary team. For this case study, what is necessary to know is that two biologically and culturally distinct populations inhabited the area. The first is called the Kitoi. They lived in the early Neolithic from about 8,800 to 7,000 years ago, and the second is called the Isakovo-Serovo. They lived in the late Neolithic from about 6,000 to 5,200 years ago. And there is a gap of approximately 1,000 years between these two populations. Both populations created cemeteries for their dead, something rather rare for hunter-gatherers, so this provides a valuable opportunity to research hunter-gatherer human remains and learn more about the life ways of such populations from colder climate. It's not known why the Kitoi disappeared from the archaeological record. Did they move elsewhere, and if so, why? Did they change their mortuary customs such that they no longer buried their dead? Or did they die out, and if so, what was the cause or causes? We know when the later Isakovo-Serovo arrived, but it's not known exactly where they came from nor why they moved into the region. So, for my own research, I was interested in seeing if a difference in the breastfeeding and weaning practices of these two populations could help us understand something about what happened to the Kitoi, and if there were potentially meaningful differences between these groups. So, I assessed all of the subadult skeletons under the age of 10 years from 3 archaeological sites: the Kitoi sites of Shamanka II and Lokomotiv, and the Isakovo-Serovo component of the site of Ustira I. The total number of individuals was 49, with 23 of those under the age of 4 years, and thus likely to be informative regarding breastfeeding and weaning practices. I designed a novel sampling strategy to improve our ability to determine the stage of an infant's weaning. Quite simply, I took a long bone from the arm or the leg and sampled a small piece of bone from the ends. I'm sure you'll recall these areas are called the metaphyses. Then I sampled a small piece of bone from the shaft or the diaphysis. I did this because the metaphyses are the part of the bone where new bone is being deposited. So these samples will provide a stable isotope signature that reflects the most recent period prior to death. The sample from the diaphysis will reflect an earlier, younger age. The pattern of stable nitrogen isotope values within the bone then reveals if the infant was still in a phase of heavy breastfeeding, depicted by higher stable nitrogen isotope ratios at the metaphysis than at the diaphysis, or whether weaning was underway or completed, as suggested by lower nitrogen isotope values at the metaphysis than the diaphysis. So what were the results? The intra-long bone sampling approach was very successful in allowing me to determine which infants were still receiving the majority of their protein from breast milk versus those that were being weaned or were weaned. For both populations, breast milk was an important food until the age of 2 to 3 years, but there were some differences. For the Kitoi, their infants were not fully weaned until the age of 3.5 to 4 years. The Isakovo-Serovo, however, had infants that were completely weaned by the age of 3. The Isakovo-Serovo also may have had a more gradual weaning process than the Kitoi. So, Could this somewhat subtle difference in weaning practices have been a factor in the Ketoi disappearance or in the Issacovo-Sarova's success? Well, first we have to consider the effect of breastfeeding on a population's demographic pattern. Breastfeeding is energetically expensive for the mother, and if frequent and regular enough can cause infertility or low fertility. So a longer breastfeeding period could have meant there was a longer period of time between subsequent children and an overall lower number of children per woman. This could have, over time, led to a population declining in size. The Issacovo-Sarova, in comparison, may have been able to grow in size. Also, because of their potentially more gradual weaning period, this might have limited the amount of physiological stress that can accompany the weaning process. The Ketoi, with their possibly more abrupt withdrawal of breast milk, may have caused more physiological stress in their infants, possibly a factor in their early deaths. In conclusion, this research found broad similarities and subtle differences in the infant feeding practices of these two different Siberian hunter-gatherer populations. The differences may have contributed to a declining population size in the Ketoi, which may be why they became archaeologically invisible. Perhaps after many generations, their numbers decreased to a size that they no longer used formal cemeteries. Or perhaps their smaller size was a factor in their decision to move elsewhere. Likely we will never know the full story, but there is another piece to the puzzle that you'll hear about in the next video. In this video, you learned about the application of stable nitrogen isotopes to reconstruct the breastfeeding and weaning practices of ancient hunter-gatherer populations from Siberia. Coming up next, we will continue with these Siberian hunter-gatherers to explore additional ways in which we can infer aspects of their diet. We'll begin by focusing on the main foods the people ate, and end by assessing if their food sources were adequate throughout the entire year.